Welcome to the deep dive. We take your curiosity, our research, a stack of sources, and distill it all down into, well, what you need to know to be truly well informed. Today, we're looking at something, a scenario that a lot of people dream about, maybe even actively plan for. I'm talking about that peaceful retirement, often pictured right next to a beautiful golf course. Just imagine it for a second. Those perfect green landscapes, maybe the sound of clubs hitting balls, a nice community leisure time. It sounds, well, pretty idyllic, doesn't it?
It really does. That picture of tranquility is incredibly appealing.
But what if that exact setting, that peaceful image, actually held a hidden and pretty significant health risk? What if living near that perfect fairway could maybe dramatically increase your risk of developing a serious neurological condition?
Hmm, that's quite a twist on the dream.
Exactly. And that's the tough question we're diving into today. We're looking at a new large-scale study, and frankly, it's a bit concerning, suggesting a link between living near golf courses and a much higher risk of Parkinson's disease. So our mission here is clear. We're going to unpack the study's findings, try to understand the how and the why behind this unexpected connection. And more importantly, what does this actually mean for you if you're thinking about, or maybe already living in one of these areas? It's about being aware, not necessarily alarmed. Okay, let's unpack this.
Right. It's definitely a headline that grabs your attention. And, you know, it could understandably cause some immediate concern, especially for folks planning that specific lifestyle. But what's really fascinating here, I think, beyond that initial reaction, is how this study goes way beyond just anecdotes or smaller observations we might have heard before. It uses really strong population-level data to look at what seems like a potentially significant public health issue.
Yeah, moving beyond just whispers.
Exactly. And like you said, our goal isn't to scare people, but to really look closely at the science, the methodology they used, and figure out the bigger implications for public health, especially when it comes to our living environments. Because the study doesn't just wave a red flag, it actually points to specific, common chemicals, things used in groundskeeping, as the likely culprits. Understanding those is key.
Absolutely. And the appeal of golf course living, it's huge. Our source material mentions that something like at least half of would-be retirees want to spend their golden years on, or at least near a golf course.
Half. That's a massive number.
It is. It's not niche at all. People are drawn to the quiet, the community feel, easy access to recreation. Golf, walking, clubhouses, you name it. And let's be honest, those perfect green lawns are just beautiful to look at. It really represents peace and, a certain quality of life.
A well-deserved reward
Yeah.
for many.
But that's where the tension lies, right? This new study doesn't just nudge that perception, it kind of tackles it head on. It suggests that this very choice could dramatically drive up one's risk of developing Parkinson's disease.
That's a stark contrast.
It really is. It forces us to rethink what we consider a healthy place to live long term. An environment we thought was all about relaxation might actually harbor a hazard.
And maybe we should just quickly touch on Parkinson's itself, just to frame why this link is so important.
Good idea.
So Parkinson's, it's a progressive neurodegenerative disorder. It mainly affects the nerve cells in the brain that produce dopamine, which is crucial for smooth, controlled movement. Symptoms usually start small, maybe a slight tremor in one hand, but over time they can include stiffness, slowness of movement, balance problems.
Things that really impact daily life.
Hugely. And it can also bring non-motor symptoms like sleep issues, mood changes, even cognitive difficulties later on. And since it's progressive, and unfortunately there's no cure currently, any potential environmental factor that might contribute to it, even indirectly, becomes incredibly significant from a public health standpoint. Prevention is key.
So the study points to, as you said, a culprit.
Yes, and they specifically call it incidental exposure to pesticides, lingering in the air and seeping into the water supply.
Okay, incidental exposure. Let's break that down.
Right, this is really important. We're not talking about the groundskeepers, the people actually spraying the chemicals as part of their job. That's occupational exposure, a different thing.
Okay.
Incidental means the average person living nearby. Someone just, having coffee on their patio, walking the dog, breathing the air, maybe drinking the local water. They're being exposed passively, often without even knowing it, just by being in that environment.
So it shifts from a workplace risk to a community health risk.
Precisely. It affects anyone within a certain radius, potentially. It makes the golf course itself a possible source of environmental exposure for the whole neighborhood.
And the study names names, doesn't it? It mentions specific chemicals.
It does. It highlights neurotoxins such as chlorpyrifos and maneb.
And these aren't rare, obscure things.
Not at all. The source says they've long been groundskeeping mainstays. Why? Because they're really good at keeping those fairways and greens looking perfect.
Okay, so they're effective, which means they're widely used.
Exactly. That perfect green look doesn't just happen naturally. It often involves consistent use of powerful chemicals. Chlorpyrifos, for example, it's an insecticide, disrupts the nervous system of bugs.
Uh-huh.
And maneb is a fungicide, tackles fungal diseases on the turf. They're designed to be potent against pests and fungi.
But that potency might have unintended consequences for humans.
That seems to be the concern, yes.
And it's worth pointing out this isn't coming completely out of the blue, scientifically speaking.
No, that's a good point.
The source notes that earlier studies have shown links between chemicals like these and the development of Parkinson's.
Right. There's been a building body of evidence.
So this new study isn't introducing a totally novel idea, but it's providing much stronger population-level evidence. It's a big step up in terms of data and methodology.
Absolutely.
Yeah.
It takes those earlier suspicions and reinforces them significantly with a much broader data set and a more rigorous approach. It moves the needle from maybe there's a link towards there very likely is a link.
Mm-hmm.
And maybe we can delve deeper into why these are called neurotoxins.
Yeah, what does that actually mean?
Simply put, neurotoxins are substances that harm nerve tissue. And in the context of Parkinson's, which involves the breakdown of specific nerve cells, well, you can see the direct relevance.
Okay.
These chemicals can interfere with essential processes in our nerve cells. Maybe they mess with the chemical signals nerves use to talk to each other, the neurotransmitters, or they cause something called oxidative stress, which damages cells.
So the way they harm pests might have parallels in humans.
Unfortunately, yes. Some of the biological pathways they disrupt in insects or fungi can have unintended negative effects in our own nervous systems.
And the fact that they're mainstays, not just used occasionally.
That's huge. It means there's standard practice applied routinely, often over large areas, and throughout the growing season.
So the potential for exposure isn't just a one-off, it's persistent.
Exactly. It creates this continuous environmental load of potentially harmful substances near where people live, which really increases the scope and duration of potential exposure. It's much more pervasive than if they were used, say, once a year.
It really highlights the connection between our environment and long-term health, doesn't it?
It absolutely does. It's a powerful example of that complex interplay. We often focus on genetics or lifestyle, but this shows how subtle things in our surroundings, the air, the water, can play a major role in chronic diseases like Parkinson's.
Yeah.
It shows how practices in one area, like landscape maintenance, can have these far-reaching, unexpected public health consequences beyond the boundaries of the golf course itself.
It really forces a rethink of what a healthy environment actually is. It's not just about looking nice.
Precisely. Are we trading those beautiful views for potential health risks without realizing it? That's the underlying question.
And the scientific backing for this study is really strong. We're talking about researchers from top institutions.
Yes, the Mayo Clinic, University of Kansas Medical Center, University of Rochester Medical Center. These aren't small players. They're highly reputable centers.
That definitely adds credibility. This wasn't a casual look. It was a serious, rigorous investigation.
Absolutely.
And the data they used was massive, right, from the Rochester Epidemiology Project.
Yes, they tapped into data from over 5,500 people in Minnesota and Wisconsin using that project.
And that project, it's basically a huge long-term database linking medical records and addresses.
Exactly. It's an incredibly rich resource. It gives researchers access to decades of health history and where people lived, which is invaluable for this kind of study.
Yep.
It provides a really detailed population-level picture.
So how did they actually use that data? What was the study design?
Well, they started by linking the medical histories with residential addresses. Then, crucially, they identified 419 Parkinson's patients
Okay.
and compared them to a much larger group, over 5,100 people, who didn't have Parkinson's. These were the matched controls.
Matched controls. Why is that specific part so important?
Because it allows for a fair comparison. They tried to make the control group as similar as possible to the Parkinson's group in terms of age, sex, and other factors, except for the disease itself.
Like comparing apples to apples?
Precisely. It helps isolate the specific factor you're interested in this case, living near a golf course, from other things that might also influence Parkinson's risk.
And they controlled for other factors too, didn't they? Like age, income?
Yes, they statistically adjusted for age, sex, race, income, how often people used healthcare, and whether they lived in a rural or urban area.
Why go to all that trouble?
Because all those things could potentially confuse the results. For example, Parkinson's is more common in older people, Maybe wealthier people are more likely to live near golf courses.
Ah, okay.
By controlling for these variables, they could be much more confident that any link they found between golf course proximity and Parkinson's was a real association, not just caused by, say, age differences between the groups.
It isolates the golf course factor.
Exactly. It strengthens the findings significantly. And when you mentioned they used advanced statistical models,
Mm-hmm.
that's really about dealing with all that complexity you just described.
Right. It's not just simple counting.
No, these models, things like regression analysis, allow researchers to look for patterns while mathematically filtering out the influence of all those other factors, age, income, etc.
Like finding a specific signal and a lot of background noise.
That's a great analogy.
Yeah.
It helps ensure that the connection they identify is more likely to be a true, independent relationship, getting them closer to suggesting causality, not just correlation.
And doing this on a large population scale makes a difference too, doesn't it, compared to smaller studies?
Oh, absolutely. A population-based study like this one, drawing from such a comprehensive database across 2 states, gives you a much broader view.
It's more generalizable.
Exactly. Smaller studies might find something interesting in one town, but it might not apply elsewhere. This kind of large-scale epidemiology looks for trends across thousands of diverse people. It answers that crucial question. How do you go from a few hints or small studies to solid evidence that warrants public health attention? This methodology provides that bridge.
Okay. And the matched controls are the foundation for that comparison.
They really are. Without comparing the Parkinson's patients to a similar group without the disease, you can't reliably figure out what factors might be increasing the risk.
You need that baseline.
You absolutely do. It's fundamental to good epidemiological research. Is how you isolate the variable you're studying, proximity to golf courses, with as much precision as possible in a real-world setting.
Okay, so let's get to the main event. What was the big finding on proximity?
This is the one that really jumps out.
Yeah, the study found that people living within 1 mile of a golf course had more than twice the odds of being diagnosed with Parkinson's compared to those living more than 6 miles away.
More than double. That's significant.
It really is. It's not a small increase. It suggests a major elevation in risk just based on where your house is relative to a golf course. Double the odds within that mile.
Wow.
And it wasn't just an on-off switch at 1 mile, was it? There was more nuance.
No, and this is another really important piece. They found a clear dose-response relationship.
Dose response, meaning
The closer you lived, the higher the risk. The study showed the risk was still elevated for people living up to 3 miles away, although maybe not quite as high as within 1 mile.
Okay.
And then, after about 3 miles, that connection started to fade out. It suggests there might be a kind of threshold distance.
So it's a gradient. Closer means higher risk, and it gradually decreases with distance.
Exactly. And that kind of gradient is actually very strong evidence in these types of studies. It makes the link seem much more likely to be causal.
The researchers themselves were pretty clear about this, weren't they?
They were. They stated directly. Our results showed a clear dose-response relationship. People living closer to golf courses were at significantly greater risk for Parkinson's.
That direct language, significantly greater risk, really stands out.
It does. It shows their confidence in that finding, which, as I said, is a really persuasive piece of evidence when you see that dose-response pattern.
Yeah, that makes intuitive sense. More exposure, more effect.
That's the core idea. If you see that gradient, consistently more exposure, more risk, it really strengthens the argument that the exposure itself is driving the outcome, rather than it just being a coincidence.
And what about that idea of the risk fading after 3 miles? The potential threshold?
Well, speculating on why 3 miles is interesting. It likely relates to how these specific chemicals disperse and break down in the environment.
Okay.
For airborne stuff, wind patterns, weather, buildings all play a role in how far particles travel before their concentration drops below a level that has a measurable biological impact.
And for water?
For waterborne contaminants, it could be about dilution in the groundwater, how fast the chemicals degrade, or just the physical reach of the affected aquifers.
So that 3-mile mark gives a potential clue about how far the significant impact zone extends.
Exactly. And that's incredibly important practically. It starts to define a distance where the observed risk drops off considerably.
Which has implications for, say, planning where new houses are built.
Absolutely.
Yeah.
If you have a scientifically suggested threshold, even a preliminary one, it gives planners and policymakers something concrete to work with.
Right.
It moves beyond just a general worry and provides actual distances to consider for zoning, new developments, or assessing existing communities. It suggests that how close you are really matters.
Okay, so proximity is key. And there's that dose response. But the study also looked at how people might be getting exposed, right? Starting with water.
Yes, they drilled down into the pathways, and water contamination was a major one they identified.
What did they find there specifically?
They found higher risk levels for people whose drinking water came from groundwater service areas that actually included a golf course.
Groundwater service areas? So areas relying on wells drawing water from underground?
Essentially, yes. Aquifers that are potentially impacted by what's happening on the surface, like pesticide application on a golf course within that area.
And the risk level associated with that water source.
Again, quite stark. Nearly double the odds of Parkinson's for those residents compared to people in similar areas without a golf course in their groundwater service area.
Wow, there's that doubling of risk again, but tied specifically to the water source.
Exactly. It suggests the water itself is a significant vector for exposure in those areas.
And did geology play a role? Did the type of land matter?
It did. They found even higher risks in what they called vulnerable areas.
Vulnerable how?
These were places with shallow bedrock or coarse soil, basically ground conditions that allow pesticides to leak more easily from the surface down into the aquifers, the underground water sources.
So the natural landscape can make some areas more susceptible to contamination.
Precisely. The physical makeup of the ground acts as less of a barrier, less of a natural filter in those spots. And to understand that better, aquifers are like these underground layers of rock or sand that hold water. Think of them as natural reservoirs.
Got it.
Now, if the soil above is coarse, like sand, or the protective bedrock layer is thin or fractured, water and anything dissolved in it, like pesticides, can travel down much faster.
Compared to, say, dense clay soil.
Exactly.
Yeah.
Dense clay would slow it right down, acting as a better barrier. So in these vulnerable areas, the pathway for contamination from the golf course surface into the drinking water source is much more direct and rapid.
And how many people in the study actually relied on this groundwater? Was it a small group?
Not at all. This was another striking point. Over three-quarters, 77% of the people in the study lived in these groundwater-based service areas.
77%.
Yeah. So we're not talking about a niche problem. The majority of the population studied relied on water sources that could potentially be affected, highlighting how widespread this vulnerability might be.
Which leads to questions about municipal water systems.
Absolutely. The findings suggest that shared municipal wells drawing water from these potentially contaminated groundwater areas could be a major point of exposure.
So it raises questions like, are these systems testing for these specific pesticides?
Right. Are they testing adequately? Are the treatment methods effective against these types of chemicals? Are there proper regulations about how close wells can be to potential contamination sources like golf courses?
It shifts the focus to public infrastructure and oversight.
Definitely. It becomes a systemic issue about managing shared water resources safely, especially where groundwater is the main source and golf courses are nearby.
Okay, so water is a big pathway, especially in vulnerable groundwater areas, but the study found that wasn't the whole story, correct?
Correct, and this is really interesting. Even after they statistically accounted for the water contamination risk,
So they kind of removed its effect in the analysis.
yeah, they adjusted for it. They still found that just living close by, proximity alone, carried an elevated Parkinson's risk, particularly in urban areas.
And the implication there is?
Airborne pesticide residue. It suggests that even if your water is perfectly clean, you might still be exposed through the air you breathe just by living near the course.
So potentially a double whammy air and water exposure for some people.
Potentially, yes.
And why specifically urban areas for the airborne risk? That seems a bit counterintuitive.
It does initially.
Yeah.
You might think open country would have more drift, but the author suggested that denser residential areas might actually trap airborne contaminants.
Trap them? How?
Think about tall buildings, complex street layouts. They can create weird wind patterns, block airflow, maybe create street canyons where pollutants can build up instead of dispersing freely like they would over an open field.
So the urban structure itself could lead to higher concentrations of these airborne residues.
That's the hypothesis. The density could inadvertently increase exposure for residents living right next to the source, like a golf course. And these pesticides get airborne in a few ways. Obviously, during spring, droplets can drift.
Right.
But also, chemicals can evaporate off the treated surfaces later, becoming a gas. And wind can just kick up dust or residue particles from the ground or plants that contain the pesticides.
So it's not just the moment of spraying.
No, it can be an ongoing potential for airborne exposure over time.
And that idea of trapping in urban areas.
Mm.
It means you could be breathing this stuff in just doing everyday things.
Exactly. Walking outside, sitting on your porch. It's that insidious, low-level, often unnoticed exposure that accumulates over time. That's what makes it concerning for chronic health issues.
It really makes you think about the invisible aspects of your environment.
It certainly does.
So pulling this all together, the study seems pretty unique compared to what came before.
It really does represent a significant step forward. As the source says, while there was anecdotal and occupational evidence before, this is one of the first really large-scale population studies to investigate this specific link.
So previous studies might have looked at, say, golf course workers showing higher rates.
Exactly. Or maybe focused on one specific community near a course. Those were important early clues.
But this one had much broader data.
Immense geographic and medical data that earlier studies just didn't have access to. That scale allows for much stronger, more generalizable conclusions about the risk to the wider population living nearby.
It firms up the evidence considerably.
Definitely. Large population studies like this are really powerful for identifying environmental risk factors because they look at real-world patterns in diverse groups over time. They have the statistical muscle to find consistent associations that are less likely to be due to chance.
And while those occupational studies are important,
They tell you about high-level direct exposure. This study broadens the concern dramatically to anyone just living in the vicinity, which is a much larger group of people. It makes it a community-wide environmental health issue.
now, you mentioned earlier something the study didn't find, which is also important, something about municipal wells.
Yes, that's right. They noted they didn't find an increased risk linked specifically to municipal wells overall, regardless of location.
Which sounds a bit contradictory to the groundwater finding.
It does at first glance, but the researchers offered a plausible explanation: the complexity of water treatment and distribution,
Meaning?
meaning large municipal systems often have sophisticated treatment processes designed to remove various contaminants. Plus, the water gets distributed over a wide area, which can dilute any localized contamination.
So the treatment and dilution might mask or reduce the risk from those specific wells compared to more localized groundwater sources.
Potentially, yes. The groundwater service areas, found to be at risk, might rely on shallower, less treated, more localized sources that are more directly impacted by a nearby golf course, especially in those geologically vulnerable zones.
So it doesn't cancel out the groundwater risk, it just adds nuance about different types of water systems.
Exactly. It shows things aren't simple. Treatment and distribution matter. It prevents oversimplifying the issue.
Okay, so summing up the core conclusion from the researchers.
They put it very clearly. They said their study provides biologically plausible, population-level evidence that both environmental and waterborne pesticide exposures may increase Parkinson's risk in nearby communities.
Biologically plausible, that sounds important.
It is. It means the link makes sense based on what we know about biology. We know these chemicals are neurotoxins, and Parkinson's involves nerve cell damage. So there's a known mechanism by which the exposure could cause the effect. It strengthens the case beyond just a statistical correlation.
And based on this strong evidence, they made a direct recommendation.
They did. They concluded that their findings highlight the need for tougher public health policies regarding pesticide use on golf courses, especially where people rely on groundwater.
A clear call for policy change.
A very direct call to action for policymakers to review and potentially tighten regulations on pesticide use near homes and water sources.
So what could those tougher policies actually look like?
Well, several things. Stricter rules on which pesticides can be used, maybe phasing out the riskiest ones like chlorpyrifos and maneb near residential areas, or water supplies.
Okay.
Rules about how they're applied, maybe only spraying in low wind or at times when fewer people are around. Mandating larger buffer zones between courses and homes or wells.
Buffer zones, right?
And crucially, requiring more frequent and comprehensive water testing in areas drawing groundwater near golf courses with results made public.
Transparency.
Absolutely. It could also push the industry towards more sustainable practices like integrated pest management, IPM, which uses chemicals more strategically alongside other methods.
Like biological controls or just hardier types of grass.
Exactly. Or even moving towards completely organic or pesticide-free course management, which is a growing field. There are economic factors, sure, but The long-term public health and environmental benefits could be substantial.
So this really brings it back to the individual listener, doesn't it?
It really does. If you live near a golf course or know someone who does, or are maybe thinking about moving to one,
Yeah.
this study gives you important questions to ask. What are the local rules? What pesticides are used? What's the source of your drinking water? Is your area considered geologically vulnerable?
It's about being informed about your specific situation.
Precisely. It empowers you to ask questions, engage with local officials, and advocate for safer practices if necessary. It's about making mindful choices for your own health.
So there we have it. We've unpacked how that idyllic image of golf course living might, unfortunately, come with a hidden risk, a significantly higher chance of Parkinson's disease linked to pesticide exposure through both air and water. We saw that clear dose-response pattern closer equals riskier and learned about specific chemicals like chlorpyrifos and maneb being implicated. It's definitely a reminder to look beyond the surface, even in seemingly perfect environments.
Yeah, and this deep dive really underscores how local environmental factors, things we might not even think about, can have these major long-term health impacts on populations. Which leads to, I think, a really important broader question for all of us. If this kind of incidental exposure to common pesticides can raise Parkinson's risk, what other hidden environmental factors might be shaping our health in ways we don't yet fully appreciate,
Mm.
especially as diseases like Parkinson's are expected to increase globally? How can we become more aware, more informed, more proactive about identifying and reducing these kinds of environmental risks to our well-being? It really pushes us to consider the whole complex web of influences on our health.
That is definitely a thought-provoking question to end on. Food for thought for everyone listening. Thank you for joining us on this deep dive. Stay curious, stay informed, and we'll see you next time.